welcome Dustan Kasten. Thank you. Did you know that React actually just turned 4 years old? Well, technically, it's actually 2 months from tomorrow is its 4-year-old birthday, which is quite exciting for a JavaScript framework, especially because if you compute that in human years, that's approximately 144 years old. So it's lived a quite exciting life. And in fact, I actually found a map of its travels and the places it's been. So of course, like most JavaScript frameworks, it was born at Mount DOM. Not long after, it did escape to iOS Fortress, wandered blindly through Android Forest, perhaps still there, found the indigenous people of UWP, Titanium Land. You know, it gets very exciting from there. Blessed Plains, Isle Fermata, and many, many more lands. This is quite exciting. I do not suspect that when React was initially created, they had anticipated it going to so many places so far. And this is just the beginning. Today, we're going to learn how to actually write a renderer, which allows React to go to more and more places. And we'll also talk a little bit about the history of what it was like before and how Fiverr makes it so much easier. And at 3.1 on Twitter said in his very, very popular Twitter post that custom renders will be the big React thing this or next year. But he foresees a lot of libs being shipped in this manner. There's a lot of exploration and innovation that I think can happen in this. And after this talk, hopefully you'll be confident enough to do so yourself, which you probably would not have, and I would not have advised exploring before. So let's do that. But first, let me introduce myself real quick. I am Dustan. I'm not very creative, so that is literally my Twitter handle, PlayStation handle, whatever else you may do or find me on the internet. That's where I am. I've created 2 semi-interesting things, React Hardware, which is a React renderer for hardware, very creatively named, once again. You'll hear about that more later. And Tiny React Render, which was actually the originally created for this talk, but today we're going to implement React Hardware instead because it's a bit more interesting. And lastly, I work at this company called Webflow. I will say very many good things about them afterwards in person and give you stickers if you want to hear more, or just like to collect stickers like Max's laptop, if you did notice that. That's it. So today, we're going to do some terminology review. Most of this will be, half of that will be a review of terminology that you may already be aware of from React, make sure we're at the same foundation, and talk about some of the renderer-specific terms. We're going to do a brief look at some Fiverr concepts as necessary for implementing a renderer, then naturally the renderer concepts themselves, and finally, we're going to actually build one all in less than the next 27 minutes. So, renderer, perhaps the most important word to define and talk about renderers. I am not a dictionary nor a mathematician, so I'm not going to give you a formal description of what this is, and instead I'm just going to show you a bunch of examples. So the first, you may recognize this as the traditional hello world of React. It's the counter app. When you click on things, you see it increment by 1. Props let you precede at different ones. Implementation, we're going to do a slightly weird thing. You're going to see in the props type right in the center of your screen that the render method is actually passed in as a prop, and it takes the handle it is inside of this. So this just kind of encapsulates that behavior, but not so much what the actual view is. And that allows us to, in this DOM view that you see, render that actual like DOM nodes, diff stuff. So the initial thing is renderer agnostic. Makes sense? And once again, Max's eyes might be bleeding since I have the implementation deal of the class names right in there. Sorry, I didn't use styled components. But now this lets us use that exact same component in another renderer. So a renderer is every single time you want to take React to a different place. Again, we have the generic counter, which had no render method. And we give it a render method where we give it some ReactNative views and touchable highlights and such. And you may see that the behavior, once again, works the exact same. Another renderer, in our definition of render is React blessed. So again, hopefully you can see that those are numbers indeed inside those pink boxes incrementing. The only thing we changed was our elements, but it's still React powering this in every single environment using everything you know and love from React. Two more. This is A-frame, not the official VR, but A-frame, so you can click around. And once again, even though it's a 3D world that if you had Google Glass, or not Glass, Cardboard, you could stick it on, look over, get your eyes pointing right at that little count, and click it up. And you can look the other way and see you have one already started at 5. Do the same there. And lastly, the React hardware. I didn't have an LED screen, so instead I just blink or LCD screen, LED? I don't know hardware, sorry. But the light will blink numerous times. And like anyone who's done Arduino, I managed to make LED blink and stop there. Hi. So here's a little bit of review, elements and instances. You'll see these terminologies a little bit coming up. Elements, of course, are like the kind of JavaScript objects view of what is going to be rendered. It's what React traditionally think of diffs against. So when you call render method, all those React.create element calls literally create those elements. Versus the instances, which are the actual components like class component equals React, or not equals, extends React.component. Those things, when those are instanced up inside React internals, those are instances. Which of course are both separate from components, we'll mention in a second. Reconciliation is that process that React has always done of taking this virtual DOM that we think is so cool and making it very simple to reason about. It makes it very reason-aboutable, trademark. And once again, this is the important part. This used to be called the stack reconciler, which we'll define a bit more in a second, and it will now be the fiber reconciler in the very near future, unless you like to install alpha releases like me, then it's already there. And lastly, composite and host components, which there's a little bit of like nuance reference to this. Composite components specifically are like user-created components. These exist in user land, not in React internals. In fact, something like Vue from ReactNative is actually a composite component. But all the components you write in your everyday app code are composites. Host components, on the other hand, are things that are host-specific, render-specific. So when you create a render, you're tying the React world to a specific host. So DOM is a host, iOS, Android, UWP is a host, Bless is a host, the Fermata protocol for our hardware is a host. And typically, you'll see those separated out between uppercase JSX tags and lowercase strings, or what end up being strings after Babel gets through with it. But host is the more important term for the purposes of this talk. That's really all the terminology you need to know. One of the beautiful things about Fiber and implementing render is, as we've likely come to expect from the React team, to get started, to make your next step, you only have to learn a couple of concepts and a handful of methods ideas at any point in time. So the Fiber concepts, we'll talk about, and this might not necessarily be necessary to start it, but like if you're reading, looking at the internals, knowing the difference between stack and Fiber might be useful. So how stack used to, or the previous reconciler was called stack. Not always, but it became that when Fiber came into existence. Before it was called the reconciler. Capital T, capital R, naturally, trademarked. But it worked by, like, every single time you began reconciling, it would go from your, whatever your unit of work that you wanted to do was, all the way down the tree recursively. Whereas Fiber, on the alternative side, has the ability to pause work, prioritize work, etc. So when implementing the render, the only things you really need to be aware of is the idea that certain updates are more important than others. And React Reconciler has the ability to schedule them. You don't, but you can provide hints at different points on what's going to happen. And really, the core primitive that React cares about is the unit of work that's being done. Once again, Fiber is a data structure that actually represents that unit of work. Very loosely defined. Once again, not a mathematician, so you're not going to get formal proofs. That if you want to get much better visuals and a deep dive into how that works, I highly recommend, even if you don't want to get that, I highly recommend this talk. Lynn Clark, 2 weeks ago at ReactConf, gave a cartoon intro to Fiber. It's phenomenal. If you want to look back a little bit further in time, you can find Andrew Clark gave a talk before on what is React Fiber. And this is much earlier days in React. Now actually might be a good time to put a disclaimer that I, of course, am not on the React team since I work at Webflow and just a member of the community like you. And I only halfway know what I'm talking about. Renderer concepts. So again, you only have to know 3 basic ideas to get going with a reconciler, or with to create your own renderer. The renderer is the public interface of what you're actually creating. When you see import React, import ReactDOM, ReactDOM is that renderer. So the API that is available on ReactDOM, that is a renderer. Same thing with ReactNative. When you want to implement your own, that's what you're going to do. Typically, it looks kind of like this. There's a render method. It takes that JSX element as the first argument, some sort of host container, and then finally an optional callback for when it's all done. And then whatever else you want to add on there, feel free. Unmount component node is a pretty traditional one since you might want to allow your users to clean up after themselves. You might also see things like create portal or unstable underscore create portal or unstable underscore handle errors or whatever. But if you're creating a render, probably everything's unstable. So ignore that and just go for it. Next, the reconciler. This is actually, with Fiber, the reconciler object looks like this. Create containers, update containers, and a handful of other things. Create container, update container are the only ones we actually care about today. They're the only ones, well, the bottom ones are used, but performance priority, I don't think any renderers are using yet. But of course, they're just trying to get it shipped. But that allows you to, as a renderer implementer, say what updates are more important than others inside your world. And lastly, we have the host config. And this is much more interesting. This you can think of like the React component API, only not quite so clearly defined. Of course, with the component API, everything like component did mount, will receive props, did update. Everything is very clearly defined to components and lifecycles. This is a little bit looser as far as like the clear-cut demarcations for what the different segments are. So I've arbitrarily organized it in a way that sort of makes sense to me at this point in time. And with that, we're actually going to do it. So begin, this is going to get a tiny bit hand-wavy for the first 2 lines. I promise to be less hand-wavy afterwards. Right now, to implement a renderer, you have to do something weird like install ReactDOM or React Test Render or one of the many other renderers. Just like before, only now you only need to grab 2 internal methods. Eventually, hopefully by the 16.0 official release, maybe after someone on the official team could tell you I'm telling the truth or not on this point. But yeah, it's this one method. Actually, only the first one is needed to create the render. The second is for a nice to have if you want to integrate with the React Dev tools, which is very convenient that it's quite simply that easy these days. And these are the kind of types that, if you recall from our terms earlier, that we need to be aware of and that we care about when implementing React hardware. We actually are going to implement the React hardware library right now. This is more or less copy-pasted from the implementation. And I hope by doing this, you'll see that it's actually quite simple to explore this. Once again, you never would have before dreamed of creating an alternative ReactDOM renderer. If you did, you would have created Inferno or Preact. Now you can actually create a separate ReactDOM renderer exploring different trade-offs to what the official implementation is. But host context and container in our situation are the exact same thing. It's just the actual Fermata board instance being passed in. Props are what you expect. It's any bag of props that comes in from the consumer. And then our instance is kind of the bread and butter of what we care about. This is what our thing looks like internally, our host instance. In ReactDOM, you would see like document.create element for this. In our scenario, we just have the props type, and we want to keep a handle to that actual board instance at all times. So let's begin. Const hardware reconciler equals ReactVR reconciler. Just a factory function. You have it, that big object. So the object we're handing it is actually that host context object from the previous slide. So about 21 plus or minus methods as of React version 16 alpha 4. And since I've been here, alpha 6 has been released, so there may be a few nuanced differences, but that's it. So the first thing we're going to do is look at the new Fiber features. We mentioned how Fiber can time slice its work and prioritize certain updates over the other. To enable that, you just say use sync scheduling equals true. If you do so, you need to actually define these other schedule animation callbacks, schedule deferred callback, and possibly should deprioritize subtree. So these are like the new things that Fiber enables. And if you were to implement these, you need to have the same semantics as window request animation frame and window request idle callback, which is a new API. It doesn't, like the convenient thing about it not actually just being set to those things is you can implement it for whatever world you want to integrate with. So whether you are actually inside of the browser or inside of a terminal or inside of an iOS device, as long as you have those semantics, it will work. And then should deprioritize subtree is another hook for React to deprioritize work as it's going through. I'd say who's familiar with React Virtualize, but I can literally see none of you outside the first row, so I'll just pretend you all raise your hand. React Virtualized or virtual windowing, if you've heard of these terms or haven't, is the idea that certain work is more important than others in a giant list view, and you only care about doing the work for stuff on screen. So should deprioritize subtree is like a way for you to work with React itself to actually solve that problem of only doing the work for stuff on screen, not off screen, or whatever else would make sense. So in this situation, like if you're in ReactDOM, you might say if props.hidden equals true, ignore this work until the future. React Fiber internally breaks things up into kind of 3 different stages. There's the begin work, complete work, and then commit work. So we saw the unit of work. So when you begin work, React is going to actually begin processing that part of the tree. It may or may not complete. And when it does complete, that next set will be called. And that's all still like in the virtual DOM world. When it wants to flush that to the actual host environment, it will call prepare for commit and reset after commit. And these, like most methods that we're going to see, exist specifically because of ReactDOM. To expound, if you were implementing ReactDOM, if you were ReactDOM, you might do something like re-implement the entire event system in JavaScript, which might sound crazy, but it also is very useful and allows you to that before commit, disable your entire event system to flush those changes and then reapply it afterwards. Or if something's selected on screen or inside of an input, save what that is, flush all the changes, and then reselect what was previously selected. And the reason that's important is because when you apply changes to the browser DOM, it might trigger side effects such as events or updating values or changing what's selected. And React wants to control and own that and not call certain like your event callbacks just because something was flushed to the screen side effect. So I honestly believe that every single renderer just has no ops for these, except ReactDOM. But if you're working in a world that has side effects when you flush things, you have your hooks. Up next is get root host context, get child host context. In our situation in React hardware, once again, we need to, the most important thing in React hardware is that reference to the root board, because that has all the API methods to actually update what's going on inside your Arduino. In child host context, like we're doing nothing, so just return an empty object. It actually is very important to return the same empty object every time because it does like an identity check every time. It needs to push or pop from this host context stack, and it would just kind of grow indefinitely and incorrectly without it. And to be clear, this context is separate than what you expect from the public API of context. This is actually host context as one word, which you may have seen earlier. Once again, we can thank ReactDOM. Well, not ReactDOM. OK, we can thank the browser for this existing. I'll start blaming the browser instead of React. Since, as we all know, React exists to make us not have to deal with the browser. The host context, for example, in the browser, is if you're in an HTML tree and you switch to an SVG tree, the methods that need to be called and the arguments that need to be provided them are different. So React needs a way to track where it is in the tree while performing work. And that is what these things are used for. Especially because you can get really weird going from an HTML tree to an SVG tree, back to an HTML, to a MathML, to some form of an object with something else in there. So again, you're hooked for that. When you begin working, you can probably just make these no-ops or empty object returns. Get public instance is another real quick one we can go through. It exists. This one's not because of ReactDOM. React Test Renderer made this one possible. I would say 99.9999% of the time, it should just be the identity function today. That may change and may be more useful in the future. It may go away in the future. But for now, get public instance has to exist, identity function. All right, now it starts to get a little bit more interesting. We need to create instances, text instances. We'll explain why there's two separate things there in a moment. But all we're going to do in our situation is return that object literal that we defined that type for at the top, where we have that root container instance always visible, and then just type in props. In the browser, you would see document.createElement in this space. Text, in certain host environments, text is treated very differently than like first-class elements, the browser being the one to point at here once again. In our situation, honestly, I'm returning text, but I probably should just return null and like ignore it. But if text is different, you might need to be aware of like flattening your text instances or document.create text instance or text or whatever the API is, and so on. And you'll see most of the other methods, if you look at the type definition, they'll take instance or text instance. So they both will flow through most of your renderer code, and there may be some subtle differences you need to be aware of. Up next, we're going to start to enter into your traditional like tree methods with a few nuance. There's finalize initial children and append initial child. Let's see, one of these exists because of ReactDOM. Finalize initial children does. So these just get called at different point of that work cycle. They both are going to do basically the same thing. It's your hook for you to flush things to your host environment. We're just going to set that initial properties or set payload for pin in both of them. And we're just going to pass all the arguments to the implementation that actually deals with the few fermata calls, or that would deal with your few document create element or element calls. But really, we just want to pass them through. Finalize initial children, if you returned true from it, it would call a subsequent method, which we'll discuss in a minute. Otherwise, it more or less is going to behave in the same way. Append initial child, which is separate from append child, is for that first time that work is being completed. Once again, there's just reasoning for sometimes there's special use cases that happen. But 95% of the time, to make up numbers on screen, on stage, this is going to look the exact same as append child. So here we'll look at our append child, insert before, and remove child methods. In our scenario, hardware isn't actually like modeled as a tree or a linked list. So like the pin that you give, like the pin value that you give to your pin component is what matters. So we're just going to pass things through all the time, whatever it is. It doesn't matter where you move it inside your JSX, which would actually change where it is in the tree as far as React's concerned. But we're just going to just blindly send that stuff through every single time. It's only electronics. What could go wrong? In the browser, these literally just proxy straight through to parent instance. That should be parent element, actually, I think. Nope, I lied. Parent instance. Dot append child, parent instance insert before, parent instance remove child. So these are very similar to the browser APIs if you're familiar with them. Once again, hardware isn't models of the tree, so we're just going to set that value to 0 and ignore it. Up next, we have a few text-specific methods. That word commit we're seeing again with commit text update. This is if you have text separate from your elements, how are you going to update that context? Do you need to do any diffing on the old text versus new text? Same way you would see old props versus new props in many of the other methods. Reset text content. Very similar, you just need to how to empty it out, and then whether you should or should not set text content. So this is just kind of giving hints to React in some scenarios and flushing things through in the other. And as you can see, I'm not doing any work for any text in hardware. And to be honest, I think that ReactNative, just as a note, also isn't actually treating text updates or elements different than standard instances. So you can do quite a bit without having to worry about that nuanced difference, but it is there if you need it. All right, now we're nearing the end of it. Commit mount. Of course, we should be familiar with the mount term. So this is the first time work is being done. And this is the method that is called if you return true from finalized initial children. The reason mount is special is the autofocus attribute. If you want to autofocus an input, you only want that to happen the very first time that element is added to the DOM, but not for subsequent updates. You don't want to be continually refocusing. So this is that small hook to do any initial setup configuration, focusing, et cetera, if you need it. Commit update is actually far more interesting for most scenarios. Whereas most of the ones we actually looked at could probably be no ops and you'll mostly work, commit update, you do need to implement. This is where you actually have your instance and you have an update payload, possibly, or old props and new props as you see, and you apply those new props. So all we want to do is set that payload to that pin, reapply it, so call a few model calls beyond the scenes, or whatever else your host environment is, and update our pointers for things like event emitters. At least that's our very naive implementation that covers blinking LEDs and buttons. Prepare update is very interesting. This receives an instance, the type, the old props, the new props, and then a few other bookkeeping things from inside React. And this allows you to optimistically diff those properties. So if React happens to pause work before committing that update, it can reuse that work as long as the props coming down the tree haven't made this part null and void. And you can use many off-the-shelf diffing algorithms or write your own for whatever use case you have, whether you want to compare primitives separately from events, functions, et cetera. But it expects, at least in this scenario, an array of values that we'll want to apply after the fact. And that was literally the entire reconciler API. We did that API tour in 12 minutes. So if you're writing from scratch instead of listening, you could have implemented it in around that same amount of time. It's much, much easier. The barrier to entry to doing this is much, much lower. React DevTools also has phenomenal third-party integration for renderers now. If you see Dan Abramov, give him a hug, high five, candy, whatever Dan likes. I don't actually know. So ask him first. But thank him for this being so possible. You literally just grab inject internals, inject a few things. Find fiber by host instance has to be at least defined as a function for it to actually connect. But if you want to add the real semantics, I haven't had a need for this to work, and the DevTools work, and the two renders I've added it to, you would need some way to get the closest instance from, like React instance from the actual host node. Or find host instance by fiber, which is conveniently part of that reconciler API, so we can just pass that through. And then, so on the other side of this, just so you know, you can install React DevTools from Yarn, so like Yarn add React DevTools, npm add React DevTools, whichever one you prefer. And just run the CLI. It'll open up React DevTools in an Electron app, and it will connect to whatever environment you have. It's quite phenomenal. And then lastly, we're going to actually implement our public renderer so you can write things for hardware. We have our element, our container, our callback. We need to do a little bit of bookkeeping. At the very top, you'll see that root equals containers.getContainer. So containers is a JavaScript map, so we can just pass stuff to it. If it exists, we know that we've already implemented, like the user is already rendered to this container. So we're going to just call update container with the new values. Otherwise, we're going to go ahead and create it. And this is the only Fermata API that I'm going to bleed through you today. And we set up a board. It's async, so when it completes, if it fails, we tell the user it fails. Otherwise, we create that container, update it once again. So it actually tells React to go and make this thing real, and then set it so the next time someone calls it, we get it back. And we export it, because we still like CommonJS and hate tree shaking. But we did it. We implemented a renderer. So again, if you saw my talk 2 weeks ago, I'm sorry. I'm not very creative. I'm going to use the exact same closing. ReactNative adopted the idea, or the terminology, our community adopted the term, to learn once and write anywhere. And anywhere literally was just the browser or iOS. And eventually Android came along. But with Fiber, you literally can React anywhere. And with your help, we can render everywhere. Thank you. I'll wait 30 seconds for more than one vote to hit this, maybe. All right, have I thought of creating a file system renderer? I have not, but for some reason, I know I've seen one. I think it was someone from Formidable. If you worked there and it was Brandon, yell. But yeah, no, I personally haven't. I more prefer like random toys like hardware and file system. But I believe it exists. So next question. In what real-world context did I have to create a custom renderer? Hardware, I think, actually applies to real-world context. And shockingly, I did get an email a month and a half ago from a student at a university somewhere in the US who said like his boss wanted to create something in React hardware. And I said, that's awesome. Please do, and I hope it works. See, outside of that, I have a wonderful habit of finding ways to use toys that sound fun at work. So I did use React Blessed for a real project, semi-real project at my previous team. But I haven't really had one. Though I do think, I'm curious if Preact or Inferno would exist if creating alternative DOM renderers inside React would have been so easy back in the day. I suspect it still might have, because they did make some more trade-offs beyond just the API or event emitter. Yeah, I think there's a lot of possibility potential. So next, what future use case do you foresee that might require a new renderer? I guess somebody, can you predict the future? What's future UI worlds that are going to exist? Or what are future things that you could model or think of as a UI, where having the ability to have this declarative tree that gives props and renders things, I think is quite fascinating. And additionally, with the work that's going on the Reason team, I have this theoretical excitement that someday we may be able to take our loose JavaScript written for React, switch to Reason, and Reason can compile to bytecode, at which point you've fully escaped the JavaScript VM. And then if you could apply React concepts, ideas to anything else you do as a non-web developer, I think things could get interesting. Of course, there's theoretical things that sound fun, tying the React API to an AI system for some reason. I don't know how that will work or why, but it'd be interesting. Once again, I'm more motivated by what sounds fun and silly than what is practical. Let's see, next, do you think React makes sense for working with hardware, or is it more of an interesting experiment? I don't really know. It's definitely an interesting experiment. It was fun. The backstory behind that is I literally don't know anything about hardware. And I had an Arduino on my desk for 2 years, and I literally just had the LED on the board blinking. That's all I'd ever done with it. And I remember riding the bus one day. I was like, wait, if I could make React control that board, then I could do this without having to learn hardware, which is more or less what I did. Now, I think it does make a lot of things more approachable, more accessible. I do believe that applying React to worlds, whether it's hardware, VR, or anything else, it makes it more accessible to a much wider array of community. It's no surprise that so many things that can be written in JS will be written in JS. And React is the natural evolution of that. Brendan Eich has recommended learning React, so it's science. But I think you open up any other environment to a much wider array of people to get started. Now, there's probably going to be laws of physics or other things that hit at a certain point where you will need to go to a lower level or remove that abstraction. But in the trade-off scheme of things, many things become much more approachable, hardware included. Next, how do we support events? You definitely don't get it for free. You'll have to write it in some way. In ReactDOM, you'll have to apply those event listeners. In hardware, there's Fermata methods. Once again, native, there has to be a bridge. So you always have to do something to support events. But you have all the hooks you need between those 20 methods on where to start listening to events and stop listening to events. So it's very specific on what your use case is, what you want to accomplish, and what trade-offs you're OK with. What's next? Do I think a dedicated renderer for a game would be a good candidate? I do. I know Ken Wheeler created the React game engine of some sorts, but dropping down a level from implement, I'm pretty sure it's implemented at the component level right now, and dropping down a level to implement it at the renderer level, or tying it into 3JS or WebGL proper, or OpenGL, so you can actually go between it. I think can go really far. And totally drawn a blank on his name, but everyone probably knows him because he created Doom. Did mention the other day, and he works on Oculus. I mentioned how phenomenal ReactVR was from the component level for implementing UIs, even for games. So I think there's a lot of interesting value that can come from there. Up next, how much test coverage did I achieve in the renderer? So it works. Is that test? My snapshot works. No, I have no idea what the actual coverage metric is. I actually do have tests for it, and I've rewritten it 3 times now. Yeah, enough that I feel confident putting a flashing LED on it. Not enough that I build a crossbow with it. Actually, I would if I could get it to work. All right, so a couple more, and then we're finishing. When creating React components and applications for the browser, is there anything going on in the rendering layer that we should keep in mind? With Fiber release, the API should be relatively compatible with Stack. It should behave the same as Stack, at least that's the goal. So there's nothing in the immediate future. But what this opens up in the midterm future, I think is really powerful. For example, React is great at many things. One thing it's historically not been so good at is animations. And with Fiber, that should become like a first-class citizen inside React world. If you use something like Shenglu's React Motion, it should just become faster or more performant because those kind of updates will be prioritized. But of course, with the idea of work being able to be aborted, there are potentially concerns for will that ever bleed through to the UI layer, to the user, and what control do you have as a developer to deal with those things? But I have a lot of trust in the React team. Of course, I use React heavily, so I don't think they'll be insurmountable or as painful as other unnamed JavaScript frameworks. Yeah, I'm at 39 minutes. Should I answer any of these, or should we? I think there's beverages coming up in a moment. Cheers, thank you.
Thank you very much, Dustin. OK, so we're about to take another one of our breaks. Usually they're 20 minutes, but we actually finished 10 minutes early, so you got half an hour. Bear in mind, there is booze in this break, but there is also booze at the back of this room. So if you want to kind of distribute yourself between two bits, be sure to get the booze on there and visit the stands at the back.